Now, similar thing for the second outcome, I'm not going to show because it's going to take extra time. For adverse events, we're going to do a similar, thing, but then again, I'll have to show you guys because I don't want any one of you missing on anything. So it's essentially the similar stuff, and I don't need to show it, but just to be on the safe side, I'm just gonna copy all of this stuff here as well. So once again, in the number of adverse events, we're always gonna um, you know add the number of events in this case would be the adverse events. You can also rename it as adverse events, but it's not necessary to do so. So we're gonna go to safety, and then we can see participants with number greater than one adverse event. So in placebo, we had 62 out of 403. And in terms of the Vegipan, we had 88, 97, 126. That would be 311. And the number of there, let me see if it 387, 391, 402, 403, 394, 391. So that's like 1 plus 3, 4 plus 1, 5, 5 more than the efficacy one. So 1180 plus 5, 1185. Okay. It's always better to double check that the number of patients in efficacy and safety outcomes are the same or not. Usually they are not, because people sometimes withdraw, or sometimes people are part of efficacy analysis but not a part of the safety analysis due to some reasons. So you always want to be, confirm. Now we're going to go to our adverse events at the clinical trial website, and we're going to see, yeah, others not including serious. So we're gonna have to, like, there was no serious adverse event in any one of the groups, so we're just gonna include these one. Now, of course, in the adverse events, you have to include serious plus non-serious. If you have not written it, you can also mention it right here: serious plus non-serious. That's, there you go. And now it's like 129 by 69 and 31 by 653 and 35 by 31 by 653. Sorry. There we go. See, 31 by 653 and 129 by 69. Already you can see the number of adverse events are higher in your group and your drug group. It's always like, almost always the number of adverse events are going to be higher in your drug group, which is not good. Obviously, it's not good that you're having adverse effects, but then again, it's also a testament that the drug works. So that's how you're going to pool safety outcomes. Now, another thing that I do is I always select this one and I color it green. Green means safety and yellow means efficacy. So that's what I also do. This sort of helps me differentiate between different, outcomes. So now I'm going to teach you how to pool um, any outcome which is not a categorical outcomes, right? So I'm going to teach you how to pool a continuous outcome. I'm just going to make it yellow. And once again, we're gonna do name, year, etc., etc. right here. Control C. Gonna paste it right here. Now, the thing that you're gonna do right here is mean of your drug, standard deviation of drug, total number of patients in the drug. Okay, now that's the difference. These two right columns right here are the difference. Once again, mean, placebo, ST, placebo. That's how you're gonna pool such a variable. Okay. Now what you're gonna do is, once again, create our blue partition, delete these columns for aesthetic purposes, and now we've got the safety at the end, efficacy at first. So for the, for just this example, I'm just gonna enter the values in group and Lipton, and these values are supposedly okay. All of these are supposedly. Our main name of the outcome would be time taken to relieve headache, and obviously we're gonna write mean time or average time, because obviously the time is gonna be an average of the number of minutes it took. Now, since it's a continuous variable, it's always important to add the units. So I'm gonna click here and enter the units as minutes. And let's say for the purpose of this video, I'm also gonna enter the hours right here. Okay, so I'm just gonna then mention here minutes slash hours for now. Okay, and actually never mind, I made a careless mistake of spelling, and I'm just gonna enter that. For example, in group, the drug group, on average people took 55 minutes with the standard deviation of 17 minutes, and the total in the drug group were 1180. So once again 1180 here, and 401 in placebo. 401 in total placebo. The standard deviation of placebo was 25. The reason I'm keeping the standard deviation of placebo a bit higher, actually, just make it 51. A bit higher is because obviously when you've got a placebo, it's not working with a proper mechanism, it's working by fluke or by luck. You are gonna have a higher standard deviation. So you'll almost always see that if your drug is working, the standard deviation of placebo would be almost always a bit higher than the drug, and that's how we basically extract data. So this is like the end of data extraction. In the second video, I'm gonna run analysis using the Revman software, and then we'll go on to the subgroups and baseline, etc. Actually, you know what, I'm just gonna cover the baseline. So if you go to the article, you're gonna see the first table, the table number 1, demographics and baseline characteristics. This is the baseline characteristics that I'm talking about right here. So you need to include all of these as your baseline characteristics. Now, some articles will not have all of this. For example, this one does not have the data table, but let's say that this article did not see the ethnicity or the race of the patients. So if it did not see the race of the patients, you cannot like obviously pool it here. But I'm gonna write the most important outcomes that are usually, you know, seen in the baseline characteristics. First of all, we're gonna write here as a variable. Then this will be the study names, or just enter the name of the study actually. Soup 2022, Lipton 2023, Faizan 2021, and Shazad 2024. And now we're gonna click on, we're gonna write age, then we're gonna write gender. Obviously, like these two are the most common. Then intervention, obviously you're gonna add the doses right here. And also, you know what, some people also use study design, but since we have all RCTs, it's not necessary here because we're gonna specify it in the inclusion criteria. But still, it's always better to add the study design, until unless like you have all the studies of the same design, then it's plainly stupid to add. So study design, then intervention. Also, if you've got different comparators, it's always like this one is used in network meta, that you also enter comparator, but not in this one. So I'm just gonna delete both of these. Okay, some people also like to include outcomes, but since we've got a very good baseline efficacy table made right here, we're not gonna add the outcomes. What we will add though is, what should we add? Actually, you know what? They did not, like I said, they did not mention, for example, they did not mention the race. So we're gonna add ethnicity. So we're gonna add the ethnicity right here. And now, of course, like since they have made divided into Hispanic and not Hispanic, we're gonna add it like as Hispanic ethnicity, Hispanic ethnicity, non Hispanic. And then we're gonna make the variable one a bit bigger. Okay. And lastly, the baseline BMI, weight, height, and like just the random stuff. Since we're adding BMI, we're not gonna add the weight and the height. BMI would cover the weight and the height both. Lastly, preventive medication use and the risk factors. And lastly, risk factors for cardiovascular disease. I'm not gonna fill this last one because it's gonna be too much of a hassle. But just to give you guys an idea, what we're gonna do is we're gonna use the age with the standard deviation right here. Okay. So then again, you've got like three of these. Okay. So now what you're gonna do is you're gonna pool all of these. But for now, we're gonna enter the placebo. And of course, when you're making this both of these groups, what you're going to do is you're going to add an additional column next to each of the study. And in this column, you're going to add drug, placebo. Okay. So that's how you do it. That's how you're going to add it. Okay. And for example, here we did it with the age, a placebo, control C. We're going to copy it here. And I'll fill this one in the next video, okay? Because this video is getting too long for now. And for example, the male one was 63, so it's basically just have to like copy it, nothing else. You just have to copy it. So that's how you do it. And also with an age, you're gonna mention that it's mean, comma, standard deviation. And in gender, you are showing the number of males, comma, percentage, because obviously otherwise they're gonna not gonna know what does 63 mean or what does 15.7 mean. So that's how you fill the baseline characteristics, and that brings us at the end of our data extraction video. Lastly, I would like to show the slide how you can connect with me. And in the end, John F. Kennedy said a meta-analysis with only two RCTs is like a man without brain. It simply cannot exist. On that note, I would like to end the video, and yes, I do love spreading misinformation. Thank you so much, and goodbye.